Biomimicry literally means imitation of the living. It is the practice of designing products and solutions inspired by nature's problem-solving skills. Planes are an obvious example, but there are many more inventions that were modeled after animals, plants, or natural structures. In 1941, Swiss engineer George de Mestral was out for a walk with his dog when he noticed burrs sticking to his clothes and his dog's fur. Curious about this natural sticking mechanism, he examined the burrs under a microscope. What he discovered were tiny hooks on the surface of the burrs, perfectly designed to catch onto the loops in fabric and fur. This is nature's clever method of seed dispersal. Burrs stick to passing animals and are carried away, spreading the plant seeds over a wider area. Seeing the potential in this natural design, Mr. de Mestral uses as an inspiration to create a new type of fastener. He replicated the hook and loop structure using synthetic materials, which led to the development of what we know today as Velcro. The Shinkansen, Japan's iconic bullet train, was, despite being a ground vehicle, inspired by a bird. Engineers were challenged by the loud noise created by the trains as they emerged from tunnels, a result of air pressure changes. Seeking a solution, they turned to the kingfisher, a bird known for its ability to dive into the water with minimal splash. The kingfisher's skills lies in its beak. The bird has a long, slender beak that reduces splash and resistance as it enters the water. This allows the kingfisher to move from air, a medium with low resistance, to water, a high resistance medium. And that's why engineers reshaped the front of the bullet train to mimic the kingfisher's beak. This new streamlined nose reduced the pressure change as trains exited tunnels, significantly cutting down the noise. The redesign also made the train more aerodynamic, increasing its speed and reducing energy consumption. Wind turbines have seen significant advancements thanks to the humpback whale. Despite their size, these creatures demonstrate remarkable agility in the water. The secret to their maneuverability lies in the unique structure of their fins. Humpback whales have large fins with distinctive bumps along the leading edge, known as tubercles. These tubercles disrupt the flow of water over the fin, reducing drag and increasing lift. This allows the whales to turn sharply, quite impressive given their size. Understanding the advantage of these tubercles, engineers have applied a similar concept to the design of wind turbine blades. By incorporating bumps akin to the whale's tubercles on the blades, they found that turbines could operate more efficiently. These modified blades generate more energy at lower wind speeds and reduce noise, a significant challenge in wind turbine design. Moreover, the addition of tubercles increases the blade's tolerance to damage and reduces the wear and tear from wind forces. In competitive swimming, a major innovation came from the deep sea, directly influencing the design of swimsuits. This innovation was based on the skin of one of nature's most streamlined swimmers, the shark. Sharks are covered in tiny tooth-like structures called denticles, which are really efficient at reducing water resistance. This adaptation allows them to glide through water with great speed without making any noise. Inspired by this natural design, swimsuit manufacturers created a new type of swimwear that mimicked the texture of shark skin. These suits greatly reduce drag, enabling swimmers to move through water with increased speed and efficiency.
Well, swimming's new Speedo Racer swimsuit is causing a stir worldwide after 10 world records were broken wearing the space-age costume. French swimming officials have called for a high-level debate, saying the suits are taking away from the swimmers' own physical performance.
Recognizing this, the International Swimming Federation stepped in and, in 2009, implemented a ban on all body-length swimsuits in competitions. The lotus plant can usually be found in muddy waters, but its leaves always appear clean and vibrant. This is because of their self-cleaning properties, a feature that has inspired numerous technological innovations. When water droplets land on a lotus leaf, they bead up and roll off due to its extremely water-repellent material, picking up dirt and debris along the way. This process is known as the lotus effect. Clean and dry leaves are crucial for photosynthesis, the process by which plants convert light into energy. Dirty or wet leaves can hinder this process by blocking sunlight and reducing the leaf's ability to breathe. Staying dry also helps to prevent the growth of potentially harmful fungi and bacteria. This natural self-cleaning mechanism of the lotus leaf has been a source of inspiration in creating artificial surfaces that mimic its properties. These include paints, textiles, and coatings that can self-clean, reducing the need for chemical cleaners and frequent maintenance. Termite mounds are designed to maintain consistent internal temperatures, irrespective of external conditions. This thermal stability is vital for termites, which require a regulated climate for the survival and proliferation of their colonies. The effectiveness of termite mounds in temperature regulation can be attributed to their intricate ventilation system, which incorporates strategically positioned vents and channels. During peak daytime temperatures, the structure's porous walls facilitate the upward movement of warm air, simultaneously drawing in cooler air from the openings at the base. In contrast, throughout colder periods, the mounds conserve heat. The architectural and engineering sectors have drawn inspiration from these natural occurring designs. Notably, architect Mick Pierce utilized termite mounds principles to develop an eco-friendly cooling system for Zimbabwe's largest commercial building. By replicating the termite mound's natural ventilation mechanisms, this building achieves stable internal temperatures with minimal reliance on conventional heating and cooling systems, leading to considerable reductions in energy consumption. Thank you so much for watching. Please like the video and subscribe to the channel if you enjoyed it. That will really help me to keep making stuff like this in the future.